Imagine a world where communication and power flow seamlessly through a single connection. In industrial automation, that's exactly what Profibus technology does. Ever wondered how process transmitters receive power and send signals at the same time, without separate wiring? Today, we're diving deep into how power and signal are carried on a Profibus transmitter. Stay till the end because we're breaking it down with an analogy you'll never forget. In the early days of industrial automation, sensors and transmitters needed separate power and communication cables, creating a tangled mess of wiring. But in the 1980s, Profibus, a revolutionary digital field bus communication protocol, changed everything. Today, we have two main types: Profibus DP, mainly for fast factory automation, and Profibus PA, designed for process automation in oil refineries, chemical plants, and power generation. But how does it send power and data at the same time? Unlike traditional systems, Profibus PA uses just two wires to deliver both power and data, thanks to a technology called Manchester Bus-Powered (MBP) transmission. Here's how it works. A steady DC voltage supplies power to the transmitter, while digital signals are superimposed onto the same line using Manchester encoding. This keeps communication synchronized and interference-free. In Manchester encoding, each bit is represented by a transition. Logic 1. Low to high transition. Logic 0. High to low transition. This ensures that the signal always has a transition in the middle of each bit period, providing synchronization. In MBP, power is embedded within the signal by modulating the voltage levels of the encoded data. Devices connected to the bus extract power using rectifiers and filters, ensuring stable DC voltage supply. Devices separate power and data using filters, capacitors, and inductors. Low-pass filters extract the power component. High-pass filters recover the Manchester encoded data. Key components of MBP system. Busmaster, transmitter, generates Manchester encoded data signals and modulates the signal to include power delivery. Bus-powered devices, receivers, extract power from the modulated signal and decode Manchester encoded data. Filtering circuits are used in receivers to separate data from power. Termination resistors ensure proper signal integrity and reduce reflections. So, how does this compare to Profibus DP? Well, Profibus DP, used in fast automation, relies on RS-485 communication with separate power lines. It's like using a separate road for delivery trucks and power lines. Meanwhile, Profibus PA integrates everything into a single, efficient pathway. So there you have it. Profibus PA revolutionized process automation by carrying both power and signal on the same two-wire system using Manchester bus-powered technology. It's efficient, safe, and built for industrial success. If you found this video helpful, give it a thumbs up, subscribe, and drop a comment below. What automation topic should we break down next? Thanks for watching, and see you in the next video.